Hi everyone. We are going to talk about standard score, in particular G-score, and how to compute the G-score using one problem. So the standard score can be used when we compare some measures, but the measures come from the different distributions with the different means and the standard deviation, or they have their own unique scale. For example, if there are math score for 2021 and the math scores for 2021 and 2024. This is the math score, but the math scores for 2021, the mean is 200 and standard deviation 10. And the math scores for 2024, the mean is 220 and standard deviation is 20. So when we pick up the one score from the two distribution, and can you say this number is higher than the other? No, we cannot compare those distribution directly. So in this case, we need to the standard score to compare some measures. So G-score is one of the standard score. In simply say, the G-score is number of the standard deviations from the mean. So I will take this distribution and I change these distribution scales into the G distribution. So the math scores for 2021, the mean is 200, right? And the standard deviation 10. So one standard deviations from the mean is 210. And 22. One minus standard deviation from the mean, that should be 190. And so on. Yep. So when we change this distribution into the G scale, so G distribution, the mean is 0, not 200. And one standard deviation from mean is the 1, not 210. And 2 standard deviation from the mean is 2, not 220. And the same thing, -1 and -2. This is the G distribution for math score for 2021. So how can we change the original distribution into the G distribution or G score? We need to one formula. This. So this is the individual score. It's like the original math score, and this is the population mean, or but some case it can be the sample mean, and this is the population's standard deviation, but it can be the sample standard deviation. Using this formula, we can transform the original measure into G-score. So, but we need to keep in mind, actually the G-score, so these G distribution is the symmetric. That means the half of this area the probability or the percent is 50%. And the other part, the one half of this area, the probability or percent is the 50%. But the standard deviation in this part, the scores are the negative value. But in this part, the right side from the mean, the G score are the positive scores. So let's move on the one problem. So what G scores represent? So what percent of all of the scores fall below G scores of the 1 plus. To compute the percent of the scores, first we need to draw the G distribution. I will draw the G distribution. So this is the mean, which is 0. But we want to know the percent of the area that below the G scores of the 1, right? So this is the +1. So we want to know this whole area, right? But as I mentioned before, 1/2 of the distribution is 50%, right? This is the half of distribution and the 50%, right? That means we only compute this area. That area the area between the 0 and the 1 is the 34.13. So we need to sum up the whole area. So 50 and the 34 point is 84.13. So other questions, you can compute with the similar way. So I hope you all enjoyed this question. Thank you.